Hello, this is Paul Thompson, and thank you for joining us for this discussion on remote visual inspection software productivity solutions. This session will be presented by Mr. Tom Britton. And before we begin, I will cover a few housekeeping items. At the bottom of your screen are icons for multiple application engagement tools which you can use. All the engagement tools are resizable and movable, so feel free to hide them, resize, and reposition them as needed to get the most out of your desktop space. You can expand your slide viewing area or maximize it to full screen by clicking on the arrows in the top right corner. If you have any questions during the webcast, you can submit them through the Q&A engagement panel. We will answer questions during the webcast as needed. We will also answer questions during the Q&A session at the end, or if we run out of time, your questions will be answered directly to you via email later. We do log all of your questions for us to be able to follow up on. A copy of today's slide deck and additional help materials are available in the resource list. We encourage you to download any of these resources or links that you may find useful. With that, let's get started. Mr. Tom Britton, thank you.
Here are the topics I'll be covering today. I'll start by describing and demonstrating the live streaming and remote control functions available on the Mentor Visual IQ video Borescope. Next, I'll introduce the menu-directed inspection app, which can be run on the Waygate Technologies video probe. I'll describe how to build, run, and create reports right on the video probe. After that, I'll describe the various options for moving data off a Waygate video Borescope. I know that there are many restrictions in using traditional USB thumb drives, and I'll describe the additional options available to move data from your video probe. Next, I'll describe a relatively new feature on the Mentor Visual IQ video probe, the ability to communicate with the turbine engine turning tool. Following that, I'll describe and demonstrate some of the assisted and specialized measurement features exclusively available from Waygate Technologies, which will provide increases in efficiency in performing measurements, as well as improved levels of accuracy and precision. Following this, I'll discuss the Inspection Manager remeasurement software tool, which allows you to remeasure video probe measurement images directly on your desktop PC. Finally, I will describe the InspectionWorks Digital Inspection Solutions platform, a cloud-based environment which can communicate directly with the Waygate Technologies Mentor Visual IQ video probe to provide data storage, management, reporting, sharing, and analysis. Let's begin with a discussion of the live video streaming capabilities of the Mentor Visual IQ. There are two core offerings. The first one is InspectionWorks Connect, which offers live video streaming over the internet, and the second is the iView Remote and the iView Remote Control feature, which offers local Wi-Fi based streaming to iOS devices. Here's a block diagram of the InspectionWorks Connect architecture. The MVIQ shown here could be in an engine shop or refinery on a Wi-Fi network, or it could be in the hands of an inspector in a wind turbine tower, where that inspector is using a smartphone as a hotspot in order to obtain internet connectivity. The PC illustration with web access below it indicates that it is a computer anywhere in the world as long as it has internet access. This PC has a zero install software configuration, that is, all that is required is to have a Chrome browser running on that PC. When it's time to have a live streaming session established, the person would, in fact, just log into the InspectionWorks Connect host and enter a valid set of session credentials, and the live streaming will begin. Initiating an InspectionWorks Connect session from a Mentor Visual IQ is quite simple. Once the MVIQ is on a Wi-Fi network, and you would join it to a network just like you do your smartphone with a username and password, all you do is touch the on-screen Connect button, followed by touching the on-screen Start Session button. The MVIQ will now set up a communication session with the InspectionWorks Connect cloud host system, which will issue a set of session credentials for the upcoming live streaming event. The Borescope inspector can call to a remote expert on his cell phone and ask him to log into InspectionWorks.com and provide the credential information that's being shown on the video probe screen, or he can press the on-screen invite key located at the bottom of the screen on the Mentor Visual IQ, enter the email address, and the MVIQ can send an email directly to the remote expert's inbox asking him to log into a video streaming session with the session ID and password credentials included in that email. Here's an example of what a remote expert would see on his PC screen, as well as what is being shown on the Mentor Visual IQ screen. Note that the remote expert and the inspector can have a text chat back and forth over the video streaming session. Here's another view of the remote expert's PC screen, along with the Mentor Visual IQ screen. Note that in this slide, the remote expert is using his on-screen telestration tools. The telestration toolbar is located on the PC's left sidebar of the image view. When the inspector has gone into freeze frame mode on the video borescope, that is, the image is frozen, the remote expert can use the telestration tools to draw circles and arrows, as well as place on-screen text. All of this information will show up as overlay data on the screen of the video borescope in the field in the hands of the inspector. In this example, the remote expert has drawn yellow lines around certain components in the image that he wishes to call attention to so that the remote inspector can pay attention and inspect in those detailed areas. I'm now going to demonstrate setting up an InspectionWorks Connect video streaming session. I do this by going to the main menu and touching Connect, and then Start Session. The Mentor now goes off and obtains a session ID and password from the InspectionWorks Connect host. I can now invite a remote expert, Tom Britton, to view this live inspection. I get a banner message on the top of my screen indicating it was sent. Once Tom joins the session, I get another banner message indicating that he has joined the session. And I go back to my live inspection. I'll get a confirmation message that he is actually seeing live video on his screen. I can now pause my video, send a chat message to Tom. He can respond back with a chat message to me. He's asking me to get closer and measure the chip that is visible down in the pipe. I'll move the video probe a little bit forward. I'll freeze the image again. Tom can continue to use his interactive telestration tools of arrows and circles and text messaging to continue an interactive inspection. I'll now discuss the iView remote features of the Mentor Visual IQ. iView Remote is a local wireless connectivity feature of the Mentor Visual IQ that allows communication and control features with an iPhone and iPad iOS device without the need for any external adapters. The iView Remote Local Streaming feature provides a simple method of allowing a second inspector to see the borescope image without the need for cables and a large external monitor setup. The iView Remote feature allows local streaming to an iOS device, as well as data transfer back and forth between the iOS device and the video borescope, as well as full touchscreen remote control from the iPhone or the iPad's touchscreen. All features that can be operated by the inspector with the borescope in his hand, including articulation, can be operated using the iPhone or iPad's touchscreen. The connection between the Mentor Visual IQ and the iOS device can be wired using an Apple Lightning cable, or the MVIQ can set itself up as a Wi-Fi hotspot, allowing the iPhone or iPad to communicate with the MVIQ. I'd now like to take a brief pause in this presentation to ask a poll question as to how many attendees are actually using a live streaming feature today. I'd now like to introduce the Menu Directed Inspection, or MDI app, which may be run on a variety of Waygate Technologies video probes. This app allows for a highly efficient method of capturing inspection data, organizing that data, and if desired, creating a Microsoft Word or PDF inspection report directly from the video borescope. At a high level, the MDI app can be thought of as a program that's loaded onto a video probe that contains a hierarchical tree structure of all the possible inspection points to be encountered during an inspection. This MDI enables consistently tagged inspection images from across a fleet of assets. The context information is correlated at the point of image capture, thereby ensuring data integrity, so you know exactly what asset a given image was taken from and what location in the asset that particular image was located in. It eliminates the need for manual note-taking. That means you don't have to correlate a little notepad on the side that gives a time and date stamp to a location associated with an image. It automatically can create an inspection report at the end of running the MDI. And again, no more meaningless inspection images. You know exactly the location of every image which was taken during an MDI inspection. I spoke earlier about an MDI having a tree-like structure. An MDI is an inspection template that's created by the users of a Waygate Technologies video probe using the MDI Builder PC-based software development tool. We provide this tool and our users create the structure of their intended inspections. Looking at the example on this page, this jet engine may have 5 top-level branches in a given MDI. Inside of these branches would be sub-branches. For example, if you went into the compressor, there may be a sub-branch of a high-pressure compressor and a low-pressure compressor. And inside of each of those, there may be different stage numbers, there may be specific blade numbers, and there may be locations on the blade that is used as an inspection point. So the MDI will allow you to develop an MDI inspection template that has 5 levels of inspection detail. You can generate reports with up to 1,600 total images, and there can be up to 2,500 total inspection points. Each of the points associated with an image capture will have a set of XML database tags associated with that image. So the fact that you are looking, for instance, at a CFM56 engine, and say you were in the high-pressure compressor, you were in stage 2, you were looking at blade 31, looking at the leading edge, all that information would be captured as metadata associated with that image, along with the higher-level engine data, such as the engine type, the serial number, the date, the inspector's name, the time of the inspection, and any fault conditions such as burns, cracks, missing thermal barrier coating, or any other such comments associated with the inspection. All of this information is stored as a set of database tags in Daikandi compatible format associated with the images which are captured. All this information is available for searching and sorting at a later date in a database. Let's take a quick look at the data which is created during a traditional non-MDI inspection. This is what you would see. You may have some videos which were captured. They will have a time and date stamp. There'll be images that are captured. They have a time and date stamp. And there's not going to be any automatically generated report associated with that. So you'd have to have a little notepad on the side that correlated any given time and date stamped image or video to the actual location in the asset where that image or video was captured. Now let's take a look at the data set, which is created automatically during an MDI inspection. The first image thumbnail indicates that it was taken in the combustion section in can number 2, and it's a fuel nozzle. The first video clip icon that's shown there indicates that it was taken in the compressor section, stage 2, and it's of a rotor blade. In the lower right-hand corner, there's an icon for a Microsoft Word report that is the inspection report that was automatically generated by the video borescope. And in the upper left-hand corner is a folder that contains all of the XML database tags associated with each of the images as well as the overall inspection. This slide shows not only that the MDI has automatically created a smart file name, as is shown below the image as HPT2 stator vane leading edge root, but that it is also automatically put on image annotation data indicating the location of this image in the asset as well. Also, a set of XML database tags associated with the actual location of the component shown in the picture in the asset are created and stored in a master MDI inspection folder, again associated with this MDI inspection event. This slide shows a sample of an MDI inspection report which was generated directly on the video borescope. The report consists of a single or multi-page cover page set and a single or multi-page end page set, which are Microsoft Word documents held in memory for the purpose of creating personalized reports. Notice that on the cover page of the MDI report that the MDI report generator on the video probe automatically created an inspection summary table indicating how many images were taken in a given major branch and if any of them were flagged for follow-up. It color codes these with green, yellow, and red. When the report is generated, you can select to create a report with all images or just flagged images. The center page shown here in this report sample is one of up to hundreds of pages which could show up in the final report, and it shows the images captured during the MDI, their location in the asset, any observations or fault conditions, which were captured from a drop-down menu during the MDI, and any free-form comments which are entered by the inspector. And if it was a measurement image, the measurement results are also listed in the table in the MDI report. Now I'm going to provide an overview of building an MDI and describe the types of features that are available in the MDI. The MDI Builder tool has a series of tabs that allow you to enter specific MDI inspection details for your inspection. The first tab is where you build your tree structure, up to 5 levels. For any given MDI branch or end node, you can define a set of fault characteristics that the inspector will have available in a drop-down menu. Also, you can include reference images or documents in the MDI so that they are available for the inspector for reference at a given branch or end node inspection point. I'll discuss this further in a few slides. I'll also discuss how to create your characterization and to load the reference documents in the next few slides. Note that on this slide, this is tab number 1, this is the portion of the tool where you link specific characterization sets and specific reference documents to a particular branch or end node inspection point. The next tab on the MDI Builder tool is where you enter data which will show up on the cover page of the MDI report. Note that you have the option of building an MDI such that it requires the inspector to enter certain data before the MDI can be run on the video probe, or certain data fields can be just listed as optional for entry by the inspector. Also notice that each of the fields has a private Dicandi tag assigned to it as shown in the far right-hand column. These tags are used in database searches and sorting operations. This page shows the portion of the MDI Builder tool where you create characterization sets, that is, data that will appear in a drop-down menu during an MDI inspection. Note that in this example, there are characterization sets called turbine, combustion, and fan, and the set of drop-down characterizations for the turbine section is shown in the right half of this slide. This slide shows the portion of the MDI Builder tool where reference materials may be loaded into the tool. Remember, it is back on the first tab where these reference images and documents are actually linked to a branch or an end inspection point. Note that a multi-page PDF document may be included as a reference document, and back on the first tab you can define a specific page or set of pages which are to be used as reference information for a specific branch or end inspection point. Now I'll review the process of loading an MDI onto a Mentor Visual IQ video borescope. Once you've created an MDI on the MDI Builder tool, you would typically load that MDI along with the personalized cover and end page onto a USB thumb drive and then install that MDI onto your video probe. For the Mentor Visual IQ video probe, this process involves touching the MDI on-screen key shown in the left image, followed by touching the Manage key. At this point, you can add or delete MDIs stored on your Mentor Visual IQ. I will now go through a summary of the process of running an MDI on a Mentor Visual IQ. This will be followed by a short video of an actual MDI inspection. Once you've selected an MDI from the thumbnail list of installed MDIs, you'll be taken to the cover page data entry screen. This is where you enter all the data that you previously defined as being required or optional back in the MDI Builder. Once you have entered all of the required data, you will then transition to the top-level MDI inspection tree. Since the Mentor Visual IQ is a touchscreen-based product, you can navigate down the branches of the MDI to arrive at an end inspection point through a series of touches on the inspection tree itself. In this screen, I've traveled down the MDI inspection tree and arrived at an end inspection point of HPT Stage 1 nozzle guide vane leading edge. See the on-screen annotation at the tip of the yellow arrow that indicates this location. This will show up on any image that I save at this time. The right-hand screen shows the MVIQ screen, which appears when I press the Save button. Note that prior to saving, I'm given the options of saving it as is with no additional information, saving it as a flagged image, generally something I would do if this image showed damage, add a free-form text comment. If I touch this key, the on-screen keyboard will appear and I can enter text. I can choose observations from a drop-down menu to be associated with this image. Remember, that's items such as crack, burn, missing material, all those items that you added during the MDI building phase. Or you can add an audio clip, which will be saved as an MP3 file with the same root file name as the MDI image that's being saved here. This slide shows two screenshots of the optional information that can be added prior to saving an image during an MDI. On the left-hand screenshot, this is the drop-down menu which is available for observations. In this case, you can see I could choose from typical, bent, corrosion, crack, FOD, missing material, or other. It also shows the optional free-form text entry to be able to create text that will be created and stored with this particular image and show up on the MDI report next to that image. In this set of screens, I'm showing that I've navigated down the MDI tree, showing an end inspection set of points. Note that in the tree there is a scorecard showing the number of images or videos which have been captured at each of these potential end nodes. Additionally, note that there have been 2 images saved at the HPT Stage 1 nozzle guide vane leading edge, and that at least one of these images was saved with a flag, causing the banner on the left-hand side of that end node location to have a red bar compared to a yellow bar for all the other end node points. In this screen, I've traveled down the MDI inspection tree and arrived at an end inspection point and recalled reference materials. Those reference materials can show up as a full screen image, or they can be recalled as split screen images with the reference materials on the right-hand side and the live image on the left-hand side. Note that I can save a copy of what's on screen of the combination of what's being shown on the left screen and the recalled image by hitting freeze and save. At any time while running an MDI, I can choose to stop the MDI and resume at a later time or generate a report. If I choose to generate a report, I will be shown a report settings page as shown on the right-hand side of this slide. On this page, I can choose to have a quick preview of the final report in PDF form. I can choose a custom cover and end page. I can choose the resolution of the images that will be included in the report. I can choose the page layout, that is, a number of images per page, and the location of the associated location information for each image on the report. I can also choose whether to generate a PDF in addition to the MS Word document, and I can edit the default file name that's created for the report. Here again is a sample of an MDI report, in this case showing a custom cover page and end page. Note that on the cover page there's a table which shows the main branches of the MDI, and they are tagged with color codes indicating whether there is any flagged images in those main branches. Remember that an MDI does not need to be a full front-to-back inspection template. It actually could be designed to define a critical inspection point or two associated with some type of a service bulletin. The MDI potentially could contain reference images showing the orientation characteristics of the view of a component at an inspection point for which the author of the MDI would like to have captured. This slide shows the data set which is created automatically when an MDI is run on a video probe. A master MDI folder is created with the default name of the MDI type concatenated with the serial number of the asset being inspected. Inside of this folder are all the full resolution images and videos which were taken during the MDI, a subfolder with a set of XML database tags, an MDI tree structure reference file, and a copy of any MS Word or PDF reports which were generated during the MDI. The bottom half of this slide shows the steps that are needed to easily upload this MDI folder or in fact any data file to the Waygate Technologies InspectionWorks Insight AWS cloud. The steps are pretty simple. Just select Insight, enter your username and password, select a file or folder to be uploaded, and then begin the upload. Following this slide, I'm going to show a short video showing how to run an MDI on an MVIQ and generate an MDI report. This will be followed by a brief poll question as to whether or not you are currently an MDI user. I'm now going to demonstrate how to select and run an MDI on a Mentor Visual IQ. You begin by touching the MDI button. You will then be presented with a screen of available MDIs to choose from. I'll choose the NGT 1000. As soon as I make my selection, I'm presented with the cover page data entry sheet for the MDI. Note that some of this data must be entered before I can proceed with the MDI, and some is not required. Required information contains an asterisk. I begin entering the requested data by touching the box, which brings up the on-screen keyboard. I type in the information and press Done. I do this for all the required fields. When I've completed all the required entry, I press Done. I'll now be presented with a screen which allows me to choose where I'm storing this MDI. In this case, it's being stored on my G drive. Once I make that selection, I'm presented with the top-level MDI inspection tree. I can now begin my MDI inspection by touching one of the available main branches on the MDI screen. In this case, I'm going to choose the HPT. I'm going to choose Stage 1, and I'm going to choose Nozzle Guide Vanes. And I'm going to choose the leading edge. Once I freeze the image, I'm given the option of saving it with a flag, adding comments, adding an observation, or including an audio clip. So before I save, I'm going to add some comments. I can add free-form text entry by touching the comment box. I can select from a drop-down list of observations by touching the observation box. I can select multiple characterizations, including an other category. Now that I've added my comments and observations, I'm going to save this image. Note that my comments and observations are shown directly in the command buttons on the screen. You can see the smart file name associated with this image in the header banner at the top of the screen. At any time during running the MDI, I can stop the MDI and resume it later on, or I can choose to generate a report. In order to generate a report, I press the on-screen Generate a Report key. The system will now show me a screen containing the output reporting format options. I've already pre-selected to include a PDF as part of the output report. Now I'm going to select a custom cover page and a custom end page. When I touch Select, I can browse for these custom pages. They're located on my thumb drive. Once I have completed setting up the output report format, I can get a preview of this report by touching the Preview button. I can review the cover page data which is entered at the beginning of the MDI, as well as the summary table that lists how many images were taken in each of the major branches and whether any of them were flagged. If I'm satisfied with the preview, I can touch the Generate button and create a full report. You can now exit the MDI and return to live video. In the next few slides, I will discuss the various connectivity options available to support the import and export of data to and from the Mentor Visual IQ video borescope. As was previously mentioned when discussing live video streaming, the MVIQ contains a built-in Wi-Fi radio to allow it to send and receive data over a wired or wireless network connection. The MVIQ supports the features of being able to map a storage location on a network as a destination to store Borescope data, or to allow another device on that network to share a folder in the MVIQ's memory structure. The MVIQ also supports a configuration where it appears as a mass storage device when attached to a PC, similar to the way you would attach an external USB hard drive to a PC. The Mentor Visual IQ contains USB 3.0 interface ports, which allows it to support the attachment of external removable media devices, including encrypted flash drives and hard drives. In cases where USB thumb drives or other USB media types are not allowed due to cybersecurity policies, an external USB-attached DVD read-write drive may be used to export and import data to and from the Mentor Visual IQ. Note that once the MVIQ writes data to the DVD drive, the media is finalized so that no malware files may be included on that DVD at a later date. Following this slide, I'm going to ask a poll question about whether you have trouble getting data out of your video probe and onto another device. The next few slides deal with a new connectivity feature of the MVIQ, which allows for a more efficient and accurate collection of inspection data when an engine turning tool is used during a Borescope inspection. This new connectivity feature of the MVIQ allows it to communicate with a Reinstall turning tool in order to obtain engine model number and type, engine stage number, and blade number information. The MVIQ can now communicate with a Reinstall RC2000NG turning tool system over a USB data link. On the left-hand side of this slide is a copy of the MVIQ's new setup menu, which shows the options available when a turning tool is connected to the MVIQ. Note that one of the operating modes of a turning tool is an automatic full 360-degree turn of the engine with a pause at each blade in order to perform a Borescope inspection. When the turning tool is operated in this mode and connected to the MVIQ can be configured to automatically capture an image of each blade as it's rotating past the video probe's camera. Just like the MVIQ creates a smart file name and automatically generates on-screen annotation during an MDI, it provides a similar smart file naming and automatic on-image annotation feature when connected to the turning tool, as is shown in the image on the right-hand side of this slide. This slide shows the data file structure, which is created automatically by the Mentor Visual IQ when it's operating in automatic data capture mode and is attached to a turning tool. Again, note the commonality with the MDI format previously shown by having a master file folder, subfolders by a stage number, and a set of XML database tags associated with each captured image, all of these being automatically created by the MVIQ. The following video shows the automatic data capture process operating on an MVIQ when it's attached to a turning tool. This video has been captured by an MVIQ being used to inspect a CF34-8 engine. A Reinstall turning tool is also attached to the engine. There's a communication link between the MVIQ and the turning tool that allows the MVIQ to receive engine data from the turning tool. In this case, the turning tool is providing data which allows the MVIQ to create automatic on-screen annotation indicating the engine type, engine stage, and blade number. The MVIQ could have been set up to automatically capture an image of each blade as it passed by in front of the camera, but in this case it's set up for manual capture mode. You will notice that the inspector has chosen to manually save the image of blade number 21, and you can also see by the on-screen green banner that the MVIQ is saving this image with a smart file name of HPT1 blade 21 in the folder named after the engine serial number. The inspector can now continue with this inspection, saving any image along the way with a smart file name by simply pressing the Save button on the Mentor Visual IQ. In this section, I will describe some software-assisted and specialized measurement functions which provide significant productivity improvements and are exclusively offered by Waygate Technologies. This slide shows the measurement menu screen of a Mentor Visual IQ. 3 of the measurements shown here are starred to indicate that the feature has a software assist feature whereby the function automatically completes the measurement process by placing a final cursor or automatically locating a maximum or minimum point in the measurement. For the traditional depth measurement, after you create a reference plane by creating 3 cursors, the MVIQ will automatically place the 4th cursor at a point which is either at a maximum height or minimum depth from the established plane you created with those 3 cursors in the vicinity of those 3 cursors. For a depth profile measurement, when you place 2 cursors on a plane surface, the MVIQ will automatically find the highest or lowest point along a path between those 2 cursors. An extension to the depth profile measurement is the area depth profile, where the MVIQ will automatically find the highest or lowest point above or below a defined area on a plane surface. The final measurement to be discussed is a specialized measurement which is unique to Waygate Technologies. It is the ability to measure missing surface areas by projecting a reference plane from an adjacent surface in order to allow the placement of cursors in an empty space on that projected plane. This allows you, for example, to measure the missing area of a turbine blade tip which has been impacted by FOD. The following demonstration will show these 4 advanced measurements which can save significant time by avoiding manually hunting for maximum or minimum points, as well as avoiding manual calculations of missing areas based on using multiple intersecting point-to-line measurements. I'm now going to present a series of assisted measurements where the MVIQ assists in performing the measurement by automatically finding the highest point or the lowest point for a depth type of measurement. I select measurement. From the menu of available measurements, I select depth. I place my first 2 cursors. As soon as I place the 3rd cursor, the 4th point, which is the highest point relative to that reference plane that was established by these first 3 cursors, is shown as being 72 thousandths above that reference plane. Let's go take a quick look at the point cloud so we can get a better understanding of the overall geometry of the area being inspected and verify the accuracy of our cursor placement on the indication. I'm now going to use another assisted measurement type, the depth profile, to find the highest point between 2 cursors which are placed on a plane surface. Again, select measurement. This time select depth profile. The first cursor appears. I put it on one side of the weld. As soon as I touch to place the cursor on the other side of the weld, it automatically finds me the highest point between those 2 cursors. Again, let's go take a quick look at the point cloud. The depth profile has an additional view available, which is the depth profile view, which shows the actual elevation point that you can modify. You can use a joystick or your finger to move the final cursor on the reference image profile view. The final measurement type I'm going to demonstrate on this weld image is the area depth profile. Remember, when I demonstrated the depth profile, I put down 2 cursors and the system found the highest point between those 2 cursors. If I'm interested to find the highest point of this entire weld, I'd have to move my cursors one by one along the weld to be able to find the highest point. Recognizing this requirement, we developed an area depth profile measurement which will allow you to span the entire weld surface. So let me go and delete that particular measurement. Now I'll go add the area depth profile measurement. So I put down 2 cursors at first, I put my 3rd cursor down there, and what it does is conduct a series of depth profile measurements, and it finds the highest point as being 71 thousandths between the parallel lines which are established on either side of the weld. Again, I can go in to my depth profile view and find the fact that the highest point is 71 thousandths. I can also go and view the point cloud as I did before, and this time you can actually see the area which has been scanned with a series of depth profiles to find the highest elevation point. I'm now going to demonstrate how to measure the missing area on this turbine blade using the exclusive projected plane feature on the Mentor Visual IQ. I'm going to start by showing the incorrect method of doing this and the type of error that will be encountered by using an incorrect method and how it can be corrected using the measurement plane. First, I select the measurement feature. I select the area function. The first cursor appears. I put it at the beginning of the defect. I put the second cursor somewhere out in space where I believe the tip used to be. Put the 3rd cursor here. Hit done. And the system will calculate that this area right here is 660 square thousandths of an inch. Let's now go take a look at what I'm actually measuring by looking at the point cloud. And as you can see here, this is the area on the surface of the blade. Here is the surface of the blade as well. This blue box is the plane surface around this area that I've measured here. Let's rotate the point cloud and understand what am I really measuring. Well, I'm measuring this point that is somewhere way down, not on the same plane as this blade surface. You can see the blade surface is right here, and I'm measuring on a plane that is departing from this blade surface. So I could correct this by going ahead and adding what we call the measurement plane. And now if I add first cursor, second cursor, 3rd cursor, 3 cursors create a plane. I've now forced this measurement to be on this same plane as the blade surface. Let's go back and take a quick look at the point cloud, and you can see that measurement is directly on the plane associated with the blade. The alternate method of performing this measurement would have been to perform 2 separate point-to-line measurements in order to establish the lengths of these 2 segments, segment number 1 and segment number 2, and then do a point-to-point measurement for segment number 3, and then on a piece of paper then calculate the actual missing area. As you can see here, this was all done automatically for you, and each segment was listed for its segment length here, and the total area was calculated automatically. Next, I'll be discussing the PC Software Inspection Manager program, software that allows remeasurement of measurement images captured by Waygate Technologies video borescopes. This screen shows the Inspection Manager version 3.0 user interface. Inspection Manager is PC-based remeasurement software, fully compatible with the Mentor Visual IQ 3D measurement system, as well as traditional stereo on the legacy Waygate Technologies XL Go, View, and Flex products. I'll now discuss InspectionWorks, a key part of Waygate Technologies' digital inspection solutions product offerings. Let me start by describing what InspectionWorks is and then how it achieves its objectives. InspectionWorks is a secured cloud platform that helps streamline the inspection process from live data acquisition and sharing to disposition. And it achieves this by allowing connected NDT devices to collaborate with remote experts to use workflow-driven inspection applications and to centralize data storage for analysis and reporting. You remember earlier I talked about InspectionWorks Connect. That is just another feature of the InspectionWorks platform that supports the live streaming feature. This slide shows where the Mentor Visual IQ interoperates within the InspectionWorks platform. The MVIQ is truly an edge device with its ability to directly communicate with the InspectionWorks Insight cloud. Also, as previously discussed, the live video streaming feature of the Mentor Visual IQ is supported by the InspectionWorks Connect feature. In the next few slides, I'll describe some of the additional details of the InspectionWorks environment. Let me provide a high-level definition of the InspectionWorks Insight environment. It's a secured cloud storage environment that can ingest RVI inspection data directly from a video borescope or from a PC. The structure follows that of a menu-directed inspection. It has meta tag data collected directly during the inspection, making it easy to be analyzed, reported, and shared with other users or software, such as asset management software. Here's a graphic of how information can flow between inspection devices, such as the Mentor Visual IQ, the InspectionWorks Insight Cloud, and a customer's enterprise network environment. For some customers, the InspectionWorks Insight Cloud provides a complete, secure archive storage, management, and reporting platform. Other customers may require that the RVI or NDT data be delivered to their enterprise network environment, where they will conduct proprietary analytics and create asset health-based operating processes. As it is often difficult to get a device such as the Mentor Visual IQ directly onto a customer's enterprise network, the InspectionWorks Insight Cloud provides a secure, efficient method to allow inspection data to flow through the InspectionWorks Insight Cloud to a customer's enterprise network environment. In this graphic, you can see that the remote users can log in and access the data in the InspectionWorks Insight Cloud services. It's a secure environment using a single sign-on authentication process. Note that the InspectionWorks Insight Cloud is not an RVI data-specific environment. InspectionWorks Insight is agnostic. It doesn't care the format of the data which it is hosting. It is a common archive storage and analytics host for the full family of Waygate Technologies portable NDT devices. On this slide, I show a screen capture of the InspectionWorks main user interface, showing a series of inspection cards containing all the information from those specific inspection events. The data in InspectionWorks contains both inspection level attributes, such as asset serial number, technician, location, as well as object level attributes such as the section, the stage, the component type, and asset health observations. Again, InspectionWorks Insight does not restrict the data types which may be part of an overall inspection record. InspectionWorks Insight can publish and share data with others. This slide shows the InspectionWorks Insight feature of being able to review specific images contained in an inspection, including all of the metadata associated with that image. When this image is brought up, you can review the image details, add or modify asset location tags, add or modify fault characteristics, add additional comments, and you can email directly from the screen to a remote collaborator. There's an audit trail that keeps track of objects within the system. InspectionWorks Insight is capable of creating much richer reports compared to an MDI report created on a video probe. It has the ability to embed customer-specific images and tables into the report. Just like an MDI-created report, InspectionWorks Insight provides both Microsoft Word and PDF reporting formats. This final slide shows an overview of the Waygate Technologies portable NDT product types and the InspectionWorks software product categories which support them. As Waygate Technologies RVI and NDT products continue to evolve and support greater levels of digital interoperability, the features provided by the core InspectionWorks components of Plan, Store, Connect, and Insight will provide greater levels of efficiency and value to Waygate Technologies customers. Thank you for your time today. We will now begin our question and answer session. If you have not had a chance to submit your questions, please do so with the Q&A engagement tool on your console.
Hello, everyone. Good morning, good afternoon, good evening. Thank you for joining this live webinar. We will be entering the question and answer portion of our presentation. If you would like to submit any questions, you can use the Q&A tool on your console. We will answer as many questions as possible, given the time parameters. Any other questions that we do not get to, we will email you the answers. We have a few questions here now. Does the Connect session work with a, sorry, I have to expand here. Does the Connect session work with all browsers?
So the answer to that is it only works with a Google Chrome browser.
Another question that we have coming in, how many MDIs can be stored on an MVIQ?
The MVIQ has the ability to store 50 MDIs. If you reach the limit on the amount of MDIs you have stored there, there are tools, I think, as you saw in the video, where you can unload an MDI and load an alternate one on there.
Next question, does an MDI app support the use of overlay images?
Yes, it does, as a matter of fact. So an overlay image, I don't think I went into that during this session, is a semi-transparent image that you use primarily for registering your live view with a predetermined view. Say someone created a service bulletin and they want you to take an image in a particular orientation. You can actually put the orientation you would like the inspector to use to capture that image in as a reference image right in the MDI. And if you use the word overlay in the name of that actual reference image, when you pull up that reference image during the MDI, it will automatically come on screen as an overlay semi-transparent image. And you can go in there and orient your live view with the predetermined view. There's on-screen controls that let you show and hide the overlay along the way as well.
Okay, thanks, Tom.
Sure.
Another question that has come in. Can I watch a live InspectionWorks Connect video on an Android smartphone or an iPhone or iPad?
So the answer to that is yes. It's a very handy capability for a remote expert that's not always sitting in front of his PC. The restriction, as I indicated earlier, was that you have to be able to run Chrome browser. So as long as you're running a Chrome browser, you can do that.
Okay. And I have one more question queued up here now. Does the turning tool connection work with the gray handset?
So unfortunately, the answer to that is no. You need one of our new Flame handsets. When we moved to the Flame handset, we increased the processing capability and moved to an embedded Windows 10 platform. So in order to have turning tool interoperability, you will unfortunately need to upgrade to our new Flame handset.
Okay. Lava has asked a couple questions here. He firstly said hello, but then I think he wants to know if he has, if there's a record of this webinar that they can get at.
So I'm sure this is being recorded. Maybe another one of our associates here could just jump in and describe how to access this webinar after the completion here.
Sure. Yes, the webinar has been recorded, and you will get an email that will provide a link that will take you to the recording so that you can watch it as often as you need to or want to.
Okay, thank you.
Yep, we have another one coming in here now. What is the ambient condition requirements for use of equipment?
Okay, can take that. There's two different temperature specifications associated with the product. One is the overall ambient of the system itself, and the second is the tip. And so let me start by the camera. And the camera is often placed in very hot equipment that's just coming out of service. And so it can operate from a minus 25 degrees C, which is minus 13 Fahrenheit, up to 212 degrees Fahrenheit, which is 100 degrees C. The overall system ambient operating temperature is minus 25 C to plus 46 C, which is minus 13 Fahrenheit to 115 degrees Fahrenheit. Note that in really cold conditions, the LCD may require some warm-up period. The backlight itself will assist in the warming of getting the LCD to come up to full brightness.
Tom, and could you just expand on that a little bit more? He wanted to know if there was a humidity condition.
The humidity is a 95% maximum humidity, and that's a non-condensing
Okay, thank you.
specification. And just as a additional, just overall operating environment, the insertion tube itself is watertight and is good to 1 bar, which is 33 feet of water.
Okay. From the same person, they want to know if there's a maximum length to be used for this equipment.
So, Jeff, you might have a better ability to answer that. We have a combination of some standard products, and we have the ability to make custom products, and we have a version of the product called the long steer. So if I wouldn't mind have you jump in and just directly answer that question.
Yeah, I don't think there is a answer to that. Maximum length, what was described in the webinar is it can be used on our products. So if you have a specific length probe, it's going to work. Like Tom said, we make custom length probes all the way out to the long steer probes. So any standard probe through custom can be utilized with, the MDI and the InspectionWorks Connect. All of it can be used. There's no limitation there.
Right, and so our standard probe lengths are generally between 2 meters and 10 meters for the different diameters that we have available as products before getting into our long steer product line.
Okay. I don't have any other questions queued up right this second.
Okay. All right. Well, thank you, everyone. If you had any other questions that you think of that you didn't get a chance to enter during this webinar, you can still enter them, and we will respond to you with an email with your specific question, which is to the question you're specific answer to the question you're presenting.
Hey,
All
Tom.
Right.
Oops. Yep. Sorry, Tom. There is one other question that just popped in. What is the latest version of MDI Builder?
I believe it's 2.0. I can open it up and verify that as we're talking here.
Yeah.
Give me about 30 seconds. I'll go to the About screen, version 3.0.2.
Okay, thank you. And I think that's all the questions that we have had come in. Any questions that we did not answer will be answered through email.
Okay, so again, I'd like to thank everyone for attending. Any other questions that you have, as Jeff indicated, we'll send an email. If you want to contact us directly, my email was listed in this webinar. There are a couple links to some of our web pages that were provided as in the reference information. So again, thank you, and we look forward to hearing with you and working with you.